Hey everyone, today we are going to create and simulate a mini quantum computer in our laptop using Python. First, we will learn how classical computers are different from the quantum computers. In classical computers, we use classical bits and they can have only one state, either 0 or 1 at the same time. But in quantum computers, we use quantum bits or qubits, and these bits can have multiple states. They can be either 0, 1 or both at the same time. And when something is in multiple states at the same time, it is called superposition. Now we will try to understand how actually quantum computer works. You can think of quantum computer as like spinning a coin. While spinning, it is both head and tail. Only when it lands, we can have its final value. It can be either than head or tail. So quantum computer works on the same principle. In quantum computer, we have qubits. First, we will pass the qubits through the quantum gates, which will put them into the superposition process. And after that, we will measure those qubits to get its final value. And then we will store the final result in the classical bit. Now I will show you how you can create and simulate your own quantum circuit inside your laptop using Python. So first of all, we have to install the libraries that we need. For this, you have to open your terminal, and to install the Python libraries, you have to type here pip install and the name for the libraries. The first library we need is the Qiskit, and this library is used to create the quantum circuit. And the second library we need is the Qiskit-AER, and this library we use to simulate the quantum circuit. And the last library we need is the matplotlib, and we are going to use this library to plot our final results. Now press enter in order to install these libraries. As I have already installed those libraries in my system, and now we will create our first quantum circuit. For this, you have to go into your Python file here. First, we have to import the libraries that we need. So for this, you have to type here from the Qiskit library, we are going to import the quantum circuit. And the next thing is we have to create our minimal quantum computer. So to create a quantum computer, we need 4 things. The first thing we need is the qubit. The second thing we need is the quantum gate. And the third thing is the measurement unit. And the last thing we need is the classical bit, which is used to store the final value of the qubit. So first, we are going to create a minimal quantum circuit. For this, you have to create a variable qc is equal to, and to create a quantum circuit, you have to pass this quantum circuit here, and now create a set of small brackets. Now the first argument is the number of qubits you want in your quantum computer. So I'm going to create a minimal quantum computer, so I just need 1 qubit, so I will type here 1, and next argument is the number of classical bits, and the number of classical bits should be equal to the number of qubits, because those classical bits only be used to store the final value of those qubits. So you have to type 1 here. So we have now 1 qubit and 1 classical bit. And the next thing, we have to pass our qubit through the quantum gate. For this, you have to type here qc.h, create a set of small brackets, and inside the brackets you have to pass 0. Now it will pass our qubits through the quantum gate, which will put them into the superposition. At this stage, our qubit is in both states at the same time. And next, we have to measure its final value. For this, you have to type here qc, you have to call the method measure, create a set of small brackets, and inside the brackets you have to pass 0, 0. It means you just have only 2 states, either 0 or 1. Now what it will do, it will create a qubit, then it will pass those qubits through the quantum gate, and in the end it will measure its final value, and then it will store the final value in the classical bit. So to print the circuit, you have to type here qc.draw, and inside the brackets you have to type here output is equal to text. Now save your file, go into the terminal, and to run this file you have to type here Python and the name for the file, which is test.py. Now press enter. Now here in the output you can see the circuit diagram of our minimal quantum circuit or quantum computer. Here we have created our qubit, and now it will pass this qubit through the Hadamard gate or the quantum gate. It will put them into the superposition. In this block, our qubit is in both states 0 and 1, and then we have passed it through the measurement gate, which will calculate its final value. After this, it has only one value, either 0 or 1. So in the result, we get state 0, and here C means the classical bit and 1 means is the index number. Now we have just one value stored in our classical bit. Next, if you want to make more complex quantum computer, so you have to increase increase the number of qubits in your system. Now I will make the quantum circuit with 2 qubits. For this you have to go here, you have to replace the first parameter, you have to pass 2 here. It means now we have 2 qubits in our quantum circuit, and we need the same number of classical bits here, so you have to also type 2 here. And now we are going to pass both of these qubits through the gate. So for this you have to go here and you have to type here comma space 1. Now it will push both of these qubits through the quantum gate. In our case we are applying the Hadamard gate on both of these qubits, and in the end we have to measure the final value from both of these qubits. For this you have to copy it from here and you have to go in measure and paste it here, also paste it here. Now our quantum computer has 4 possible states. It can be 0 0 0 1 1 0 or 1 1. So now we have made the quantum circuit with 2 qubits. Now save your file and go into your terminal and run it again. Now here you can see the new quantum circuit having 2 qubits. Here is our first qubit, and this qubit is passed through our Hadamard gate, and then it will pass through the measurement gate, and then we will have the final result from this qubit. And similarly this is our second qubit, it is passed through the quantum gate and then it is passed through the measurement gate, and here we have the final value of this qubit. And then we are going to store both of these values in our classical bits in the end, and here 2 means we have 2 values stored in our classical bits. So this is how you can make your quantum computer more complex with more qubits. Now we have built our circuit. Next we are going to simulate it and see how qubits actually work. For this we have to import more libraries. So first from Qiskit.visualization we have to import the plot histogram library. Next from Qiskit-AER we have to import the AER simulator, and in the last from the matplotlib library we have to import the pyplot as PLT. Now we have to create the instance of the simulator. For this you have to type here sim is equal to and the name of the simulator, which is AER simulator. Next we are going to run our quantum circuit multiple times, and then we will get its final value and we will store its result in a variable called result. And to run the simulator you have to type here sim dot run, and inside the small brackets you have to pass your quantum circuit, and the next argument you have to pass shorts like how many times you want to run your circuit. I want to run it 1024 times, and next I want to get the final result, and then I will store this final result inside this variable. Next I have to calculate the number of counts, like how often each outcome appears, and now I'm going to print these counts here. Next, to plot the histogram of these counts you have to call the function plot histogram, and inside the arguments you have to pass counts, and in the end to show the plot you have to type here plt.show. Now save your file, go into your terminal and run this file, and here you can see the final results, your quantum circuit and the possible outcomes, like how often each outcome appears. 1 1 appears at 245 times, and you can also see here in the graph, here is the number of counts and here is the number of the possible outcomes 0 0 0 1 1 0 and 1 1. This is it for today. See you next time. Bye bye.